Got to give the people, get the people what they want. All right. Need you to get this down. People have been saying, how am I going to do all this factoring? Well, guess what? We have a factoring flow chart along with some practice so we could think our way through these. This is what you're going to need to do on Friday. So you should pause it and write all this stuff down or be writing it while I'm talking about it, but please make sure you get it down. I hope that it is helpful to you. So when you're thinking through factoring, you should follow this progression, okay? First, always find a GCF. If there is a GCF, you have to find it and you have to find the right GCF. So do that first. If there's no GCF, you keep moving. If there is a GCF, factor it out. Second, so let's, that's first. Second is you decide, do I have 2 terms, do I have 3 terms, or do I have 4 terms? If you have 2 terms, most likely we're looking at these options. Is it a difference of squares? It is a difference of cubes, or is it a sum of cubes? Those all have special formulas. Use them to factor it. Now, if you are looking here at 3 terms, oh, sniggity snap, again, undo. If you're looking at 3 terms, well, is it a quadratic trinomial? In other words, x squared plus something x minus 8. You don't need to write that part, but you should know what a quadratic trinomial is. Because if it is, you need to use the area model, that box method. And finally, well, what if you have 4 terms? Here's where you're probably going to think about factoring by grouping. And remember, you may need to rearrange the order of the terms to factor by grouping. All right, so let's put this all into play with a couple of random examples. I believe we are going to do 4. All right, let's get it. So number 1, we'll start with this. I have 4a cubed minus 49a. You should go ahead and factor it, try to do that flow, but I'm going to walk you through my thoughts. Hopefully you did this before me. So let me go back here. Let me think. GCF. Does this have a GCF? I think it does. Looks like I can factor a out of this. So I'm left with 4a squared minus 49. Now, after the GCF, I'm seeing, oh, snap, I have 2 terms. Well, is it a difference of squares or a difference of cubes? 4a squared is a perfect square. 49 is a perfect square, and this is the one that I should know by heart. So this is a difference of squares. So the A term is 2a, and the B term is 7. So I end up with 2a plus 7 times 2a minus 7 because it's a difference of squares, and a difference of squares is one of those special formulas. I just factored number 1. Moving on to number 2, and again, I'm going to use the same flow chart. It says 4a squared plus 16a plus 16. So let me go back up here. Let me think about a GCF first. Does this have a GCF? Yes, I see a GCF of 4 that I can factor out of all of these, so I'm going to take that out. 4 times a squared plus 4a plus 4. Now what am I left with? Step 2. This is quadratic because this is a squared. It's a trinomial because it has 3 terms. This is a quadratic trinomial. So I should use the area model. I should use that box method. So plugging these into the box. I know a squared goes here. I know 4 goes here. I know blank times blank. These 2 boxes times each other should equal the same as this diagonal, which is 1 times 4, which is 4. And I know those 2 boxes, blank plus blank, should equal the middle term, which is 4. So what 2 numbers can I add to get 4 and multiply to get 4? 2 and 2. This is a 2a, and this is a 2a. So this becomes a times a plus 2 and plus 2. So this fully factors to 4 times a plus 2 squared. Or you could have written it 4 times a plus 2 times a plus 2. Either of those ways will work. All right, moving on to my next example. I'm going to go to a new page. Oh, no. Give me a new page below. Okay. My next example. Example 3 says, where is it at? 4y to the 4th minus 256y. All right. You guys factor that. Hopefully you paused it and just did it. But if you didn't, here's my thought process. Let me think about a GCF. Does this have a GCF? Yes. I can take y or each of those, and I can actually take 4 from each of those. So 4y is my GCF. I'm left with y cubed minus 256 divided by 4 is 64. Minus 64. Now I'm looking at that step 2. I see I have 2 terms, and I see that this is a perfect cubed, and 64 is 4 times 4 times 4. This is a perfect cube. So this is a difference of cubes. Oh, snap. I don't even remember what the formula is for a difference of cubes. But let me see if I can find that formula. Here it is, and this is a formula that you will be given. So let me just say that we know that my A term is y, and my B term is a 4. 4 times 4 is 16. 16. Yep, my B term is 4. Okay, so a difference of cubes tell me to go A plus difference. This is difference. A minus B. So y minus 4 times a squared, which is y squared, plus a times b, which is 4y, plus b squared, which is 16. So that is the factoring of the difference of cubes. And don't forget that earlier on I factored out that GCF. I am now factored. Ooh! Ooh! This is so real. Oh no, not that. Let me go here. I wonder, this is a quadratic trinomial. I wonder if this can be factored again. Let me just go ahead and check, because I have a feeling that they got sneaky with us. Y squared 16 blank times blank needs to equal 16. Blank plus blank needs to equal 4. Ooh. Oh, 16 and 4. 4 times. Oh, no. 1 and 16 is not going to work. 2 and 8 is 16, but that's not 4. 4 and 4. Okay. Maybe. I think it's done. I think it's done. I don't think I can factor anymore. Well, let me just double check here, because I know you all are going to come up with something, but I don't think that works. All right, but look at this. This is a good one. I double checked because I saw that this was a quadratic trinomial. It didn't happen to factor, but you would want to double check that just to make sure. But I think this is done right here. All right. Moving right along, let's go to my next one. It says, what was that? That was the 4y minus 4. Okay, my next one says negative 10x to the 4th plus 20x squared plus 12x. And this is the last one. All right. So let me look for a GCF. I could see a 2 and I could see an x. So I'm going to take out a 2x. I'm ending up with negative 5x cubed plus 10x plus 6. I see 3 terms, so I'd want to check to see if that's a quadratic trinomial. But this is not quadratic, so there's nothing I need to do with that. At this point, I'm done. I don't know how to do anything else with 3 terms that's not a quadratic. So this is my final answer. It wasn't the last one. There is one more. Here's your last one. This one says 28xy minus 7k minus 49x plus 4ky. All right, right away, I'm going to look for a GCF. No GCF. I see 4 terms. I'm thinking, let me factor by grouping. Usually it's first 2, second 2. But here's what I notice. Notice these 2. They have the 7s in common, but these have x's and y's. These have k's. This has an x. These have k's and y's. I'm probably going to want to put my x's together and my k's together. That probably makes sense. So let me just try that. 28xy minus 49x. Oh, yeah, that's going to work out pretty. Minus 7k plus 4ky. Put these here. Put these here. Put my plus in between. That plus is very important. And I can factor out 7. 7 goes into 28, and I can take out a 7x. So 7 goes into 28 4 times. I'm left with a 4y minus 7. Plus, this one I am going to factor out a... I'm just going to factor out a k. And I'm left with negative 7 plus 4y. Notice, negative 7, 4y. There's negative 7, there's 4y. Those are the same. So I could turn this now into 7x plus k times 4y minus 7. All right, I went through all the ways that this can be done. You got to think yourself through the process. You have so many practice problems that are posted online that you could do to get ready. I hope you guys do. Show me what you got. Bass, out.